Quantum tunneling, the key to infinite energy. What if the answer to the world's energy crisis wasn't about building a bigger solar panel or a taller wind turbine, but about using a quantum loophole so strange it feels like science fiction? We're talking about quantum tunneling. It's a phenomenon where a particle can pass straight through a solid barrier, almost like teleporting. And it might just be the key to a future of truly clean, limitless energy. A future that changes everything. But how can something that sounds so impossible even be real? To get that, we have to start with the massive problem we're trying to solve. Section 1. The problem. Our unquenchable thirst for power. Our entire civilization runs on energy. It lights our homes, powers our industries, and keeps our digital world online. And we need more of it every single year. By 2050, the world's energy appetite is expected to jump by nearly 50%. Figuring out how to meet that demand is one of the biggest challenges humanity has ever faced. For more than a century, we've relied on fossil fuels. We burned coal, oil, and gas to build the modern world. But that progress came with a heavy price. Our climate is changing, ecosystems are under threat, and the very foundation of our progress is starting to look shaky. The obvious answer is renewable energy, and it's a critical one. Solar and wind are essential pieces of the puzzle, but they have a well-known flaw. The sun sets, and the wind stops. This intermittency means we need a way to store truly massive amounts of power for when they're not producing. Our current battery technology, while improving, just isn't there yet. It's expensive, depends on mining rare materials, and isn't at the scale we need for a global switch. Plus, even green technologies leave a footprint. They take up huge amounts of land, and manufacturing them isn't a zero-emission process. So we're stuck. We need more power, but the old way is a dead end, and the new way has serious limitations. It feels like we're up against a solid wall. But what if, instead of trying to smash through it, we could just slip through it? This is where our story dives into the weird, wonderful, and frankly bizarre world of quantum mechanics. Section 2. Introducing the hero, the ghost in the machine. To find the solution, we need to think small. No, smaller than that. Way down, past molecules and atoms, to the fundamental particles that make up reality. Down here, the rules of the everyday world don't apply. Things get weird. And this is the home of our hero, quantum tunneling. So what is it? Imagine you throw a tennis ball at a concrete wall. It's simple. The ball either bounces off, or if you're a superhero, it smashes through. What it will never do is just appear on the other side, leaving the wall untouched. It doesn't have enough energy. But in the quantum world, the impossible happens all the time. Quantum mechanics tells us a particle, like an electron, isn't just a tiny dot. It's also a wave of probability. Think of it like a ripple in a pond. This wave describes where the particle is most likely to be. But when this wave hits a barrier, it doesn't just stop. A tiny part of that wave actually leaks through the barrier. That means there's a small, but real chance that the particle will just pop into existence on the other side. It didn't break the wall. It just tunneled through, even though it didn't have the energy to do so. This isn't just a theory. It's a proven fact of our universe, and it's not some obscure corner of physics. Without it, you and I wouldn't be here. The sun that powers our entire solar system runs on quantum tunneling. The sun's core is incredibly hot, but it's still not hot enough for hydrogen atoms to fuse together by brute force alone. Tunneling gives them a shortcut. It allows protons to sneak through the energy barrier that separates them, letting them fuse into helium and release the enormous energy that powers our planet. Our own star shines because of a quantum loophole. Section 3. The first clues, tunneling in our world. The fact that the sun is powered by this ghostly effect is amazing enough. But quantum tunneling isn't just for stars. It's a process that nature has been using for eons, and one our own technology already depends on. Take the device you're watching this on. The transistors in its microchips and the flash memory storing its data only work because of quantum tunneling. As we've made these parts smaller and smaller, the insulating layers became just a few atoms thick, thin enough for electrons to tunnel right through them. Engineers had to design around this quantum weirdness to make our digital lives possible. We even built tools to use it on purpose. The scanning tunneling microscope allows us to see individual atoms by measuring the rate at which electrons tunnel from a tiny needle to a surface. We can map the atomic world because we learned to listen to these quantum whispers. But nature is the real master here. Quantum effects are happening inside your own body right now. Processes like cellular respiration, the way your body makes energy, rely on electrons moving efficiently. Enzymes, the tiny machines that run our cells, use quantum tunneling to pass electrons around, making the whole process faster and more efficient. It's even involved in DNA, where a proton can sometimes tunnel from one spot to another, causing a tiny mutation, one of the engines of evolution itself. From the sun's core to our cells, from our phones to our own genetic code, quantum tunneling is a core principle of the universe. So scientists started asking a simple question. If nature uses this trick to manage energy so efficiently, why can't we? Section 4. The Quest for Clean Energy. Chapter 1. Supercharged Storage. One of the biggest hurdles for a 100% renewable grid is energy storage. We need batteries that can charge in minutes, not hours, hold huge amounts of power, and last for ages. This is where quantum tunneling research is getting really exciting. Take supercapacitors. They charge super fast, but don't hold much energy. Batteries hold a lot, but charge slowly. Scientists are working on quantum capacitors that try to get the best of both worlds. By using nanomaterials, they create electrodes so precisely engineered that electrons can tunnel right through them instead of having to climb over energy barriers. The promise? An electric car that could charge as fast as you can fill a tank of gas, or a city-scale battery that could soak up a whole afternoon of solar power and release it instantly at night. This isn't on the market today, but the results in the lab are promising. Some prototype quantum-assisted supercapacitors have shown energy densities that are starting to approach what lithium-ion batteries can do, but with the potential for much faster charging and longer lifespans. Researchers are also exploring how quantum effects could improve the batteries we already have. In a lithium-ion battery, ions physically move in and out of the electrode, which causes wear and tear. By designing electrodes at the nanoscale or using additives like carbon quantum dots, scientists hope to give the ions a quantum fast lane to travel on, potentially leading to batteries that last longer and charge faster. It's the first step, taking the weirdness that powers the sun and using it to build a better battery. Section 5. The Quest for Clean Energy. Chapter 2. Fueling the Future. Better batteries are a huge deal, but what about generating the power in the first place? It turns out quantum tunneling might also unlock completely new ways of making clean energy. Let's look at fuel cells. They generate clean electricity by reacting hydrogen with oxygen, with water as the only byproduct, but they've been held back by high costs and low durability. Here again, quantum effects could be the answer. The key reactions in a fuel cell happen on the surface of its electrodes. Researchers are experimenting with nanoscale electrode designs that could use tunneling to speed up these reactions dramatically, which could lead to smaller, cheaper, and more powerful fuel cells. But the ultimate prize has always been nuclear fusion, replicating the power of the sun on Earth. The main challenge is overcoming the massive repulsion between atomic nuclei, which requires temperatures hotter than the sun's core. It's what giant projects like the ITER reactor are trying to achieve through sheer force. But we know the sun has a secret weapon, quantum tunneling. It allows fusion to happen at lower temperatures than classical physics would allow. So, scientists are now asking a wild question. Can we enhance quantum tunneling in our own reactors? This is a highly speculative, futuristic idea, but it's being explored. Using quantum computers to run complex simulations, Researchers are trying to understand if we can create conditions that encourage particles to tunnel and fuse more easily. If we can crack that code, we won't just have a new energy source. We will have solved the energy problem for good. Section 6. The ultimate prize. Is infinite energy possible? This leads us to the big promise in the title, infinite energy. A particle teleporting through a wall seems like it's breaking the rules. So, could we use quantum tunneling to build a device that creates energy out of nothing? The answer in one word is no. This is the most important part. Quantum mechanics is strange and mind-bending, but there's one law of the universe it never breaks: the conservation of energy. You can't create energy from nothing. A particle that tunnels through a wall comes out the other side with the exact same energy it started with. It just took a shortcut reality didn't tell us about. Think of it like this. The law of energy conservation is the ultimate house rule in a casino. The house always wins. Quantum tunneling is like finding a secret door that lets you get from the blackjack table to the poker room without crossing the floor. You moved in a weird way, but you didn't magically get more chips in your pocket. In the sun, tunneling lets fusion happen, but the energy comes from converting mass into energy, just like Einstein's E=mc² says. The energy was already there. Tunneling was just the key that unlocked the door. So the idea of a quantum reactor that just spits out free energy is, as far as we know, pure science fiction. The title of this video is a provocation, a what if. But the reality is almost more exciting. Quantum tunneling doesn't give us free energy, but it offers something just as good: radical efficiency. It lets us unlock and use energy in ways we never thought possible. The goal isn't to break the laws of physics, but to use their deepest, strangest rules to our advantage. The promise isn't infinite energy, but enough energy. Clean, abundant energy for everyone. Section 7. A world transformed, the happily ever after. So let's step back from the theory for a second and just imagine the world we could build if we actually master this stuff. What does a quantum-powered future look like? It's a world where your car could fully recharge in 5 minutes, where massive grid-scale batteries store days' worth of solar and wind, making blackouts a memory. The dirty, sprawling infrastructure of the 20th century could be replaced by silent, compact, and efficient systems. Now think even bigger. Picture clean, safe fusion plants providing nearly limitless power to our cities with zero carbon and almost no long-term waste. The energy crisis would be over. Conflicts over oil and gas could become a thing of the past. Energy would no longer be a scarce resource but a basic utility for everyone, lifting entire nations out of poverty. And it wouldn't stop there. The same quantum principles would drive computing revolutions, helping us design new medicines, create better climate models, and solve problems we haven't even thought of yet. This is the potential hidden in the quantum realm. It's a future where we finally learn to work with the laws of nature, not just against them. It sounds like science fiction, but every part of this vision is based on real science happening in labs today. The road ahead is long and incredibly difficult, but for the first time, we can see a path. We can see a way through the wall. The universe is so much stranger and more amazing than it looks from the surface. Things like quantum tunneling remind us that there are still huge secrets out there waiting for us. By being curious, by daring to explore the weirdest rules of reality, we might just find the keys to our own future. The ghost in the machine might just be the hero we need. If you want to see more deep dives into the tech that will shape our world, make sure you subscribe and let us know in the comments. What part of this quantum future are you most excited to see? Thanks for watching.